So let's go into the different tests that we do. The first one is the organoleptic test. It permits the rapid segregation of the poor quality of milk at the milk receiving platform. In this, no equipment is required, but the milk grader itself, depending upon his good sense of a sight, smell and taste, he will instantly decide whether the test is obtained instantly, and you say whether the quality of the milk is good or not. But here milk which cannot be adequately judged by organoleptically, must be subjected to other more sensitive and objective tests. So basically, based upon the technician's sight, smell and the taste, we will say whether the milk is good or not. So but you have to be cautious. If the technician is not having a good smell, then you cannot analyze it. So that's the organoleptic test, which is having its own defects. The next one is a clot on boiling, or the COB tests. Okay, it's quite quick and simple here, and it is one of the old tests for too acid milk or abnormal milk. Now see, normally when the milk becomes too acidic, what happens? The pH will reduce if it is less than 5.8. Now for example, if there is the cholesterol milk, okay, the first milk, as well as mastitis milk, that is when the mammary glands have been infected, what happens? It will be too acidic, okay, and in such cases you can find out it by the clot on boiling tests. If the milk sample fails in this test, the milk must contain many acid or rennet producing microorganisms, or the milk has an abnormal high percentage of proteins like the cholesterol milk. And such milk cannot stand the heat treatment in the milk processing and must therefore be rejected. See, as you should understand one thing, every milk that we get, we do a pasteurizing test. Okay, a pasteurization procedure is being carried out for the milk before it is being marketed. Okay, so if there is a high protein content or if there is a high acid content, what happens? That such milk will not be able to withstand the heat treatment. Okay, and what happens? The coagulation of the proteins will all happen. So and that batch of milk might be rejected. So what happens when you have when you get a batch of milk itself, what happens? You have to do a clot on boiling test to check whether it is high rich in acids, or is it highly it contains more amount of proteins. So if these two conditions are there, the clot on boiling test will be failed. Now coming to the procedure, it's a very simple thing. You have to take a small amount of milk in a spoon and test, or in a test tube or any other suitable container, and if there is clotting or coagulation or precipitation, the milk is failed in the test. And heavy contamination in a freshly drawn milk cannot be detected when the acidity is below 0.2 or 0.26% of lactic acid. So that sometimes might not be detected also when the acidity is very low. Okay, so that is a defect. Now coming to the next one is the alcohol test. This test is very quick and simple. It's based upon the instability of the proteins when the level of acid or rennet are increased or acted upon the alcohol. Okay, and also increased levels of albumin, that is from the cholesterol milk, and salt concentrates and results into a positive test. Here what happens is when you are going to check, you are checking it whether the it's using an alcohol test. Okay, acting upon alcohol, what happens? The acid as well as the rennet. Rennet is an enzyme. Okay, these cannot withstand high level of alcohol. So we are going to check whether that. Okay, so you are going to check if the protein is there. Okay, when a protein or the acids are there, or when this rennet enzyme has been added also, whether you check whether these are all present with the help of the alcohol. When you add alcohol, whether they are present, they become unstable. So let's see how it's been done. So the alcohol test is used on the fresh milk to indicate whether it will coagulate on thermal processing. This process is especially important for the manufacture of UHT milk, evaporated milk and the milk powders, and it is more sensitive than the clot on boiling test, It's based upon the tendency of the milk protein to get unstable as a result of the disturbance in the mineral balance of the milk. Milk with a high developed acidity or having calcium and magnesium compounds in greater than the normal amounts will coagulate when the alcohol is added. What is coagulation? You know, when we heat the thing, what happens? Small clumps of the casein will be formed over there. So, the same way here, if you are having high amount of protein or high amount of acid or even certain ions such as calcium or magnesium compounds greater than in the normal amounts, what happens when you add alcohol, all this will get coagulated. Okay. And increased levels of albumin. Albumin is what? It's a protein. It's a protein. Albumin is also been found in the case of in egg. Okay, but in cholesterol milk albumin is present. Okay, and salt concentrates. Now in the case of mastitis you have various salt concentrates. So in all these cases what happens, if you add alcohol into it, it gives a what? A positive test, that is it will cause the coagulation of the milk. In dairy industries normally there are different concentrations of ethanol solutions which are being used, like 68% volume by volume, 65% volume by volume and 60% volume by volume, and the milk which passes 68% ethanol test is considered to be that of superior quality. And for manufacturing of UHT and the milk powders, UHT milk and milk powders, the raw milk shows about 68% of ethanol test. And the dairy is generally considered 60% ethanol test negative raw milk for manufacturing pasteurized polypack milk, as it does not have to undergo rigorous heat treatment as in the case of UHT milk. Okay. So if you are if they are giving 60% ethanol, okay, it is not, it's giving a negative result for that, means then you can take it for the milk which do not pass 60% ethanol test. That is, now for example, if you put 60% of this thing and if it is getting coagulated, what happens? Then it is it is being rejected from the processing unit. So basis depending upon the grade of alcohol test which it passes, the milk will pass through different ways. Okay, if it is to 68%, okay, if it is 68%, if it's passing the 68% alcohol test, it will go to the ultra high temperature thermal processing of the milk. Okay, and for the processes of milk powders and all that. But in the other one, and if it is even in 60% of alcohol, it is what? It is getting coagulated, means we will not use it. But if it is not getting coagulated at 60% ethanol, then we will use for the pasteurized polypack milk which we normally buy at home. Now usually the test is done by mixing equal quantities of the milk when 68 or 72% of ethanol solution in a small bottle or in a test tube. And here, if the tested milk is of good quality, there will be no coagulation, clotting or precipitation, but it is necessary to look whether small clumps are also there, that also should be looked. And the first clotting due to acid development can be seen in about 0.2 to 0.23% lactic acid. You know what happens? The clotting is mainly due to the process of, you know, when acids are there, it will cause what? Clotting. For routine tests, we use 2 ml of milk and 2 ml of 68% alcohol is being used for routine test. The principle of the alcohol test is that the hydration forces keep the protein suspended in the milk and owing to the hydrophilic property of casein. And negative charges keep these proteins repelling from each other and hence they do not agglomerate into lumps. And when you destabilize these forces, that will lead to the flocculation of the proteins. Okay. And alcohol is a dehydrator which removes the water from the system and thereby affecting the hydration forces, and it will be responsible for keeping the protein suspended. If such milk has elevated acidity due to the microbial activity, the proteins will flocculate due to the combinative effect of hydration force, destabilization and the charge neutralization. So let me just explain it to you once more. what happens is, in the case of milk, what you have casein in it, and in this casein is having a hydrophilic property. Hydrophilic property means it is having a water loving property, and it remains hydrated, and it remains suspended in the milk. That's how all the proteins in the casein is a protein of milk, so it remains hydrated. And one more thing is there, all these proteins are being found to be negatively charged, and what happens, negative and negative always repel from each other, and hence what happens, they will not agglomerate. Agglomerate means combine together and to form lumps. Okay, so when you put alcohol, what happens? Alcohol, as we know, is a dehydrating agent, that is, it removes the water. When it removes the water from the system, what happens? The proteins will get suspended. Okay, it will destabilize. Okay, and the proteins will not remain suspended, and they start what? Start precipitating out, and then what happens? They will form into, and of course you know what is it, small clumps will be formed from that. So when there is lots of microbial activity, what happens? These proteins will flocculate. Flocculate means floccules. You know what's a floccules? It's like a layer like thing into a layer like when you see bacteria growing itself, at the bottom you can see sometimes some floccules are being formed, and these will result when there is a high acidic content because of the growth of microorganisms. The milk also will produce certain floccules because of the combined effect of this hydration form post destabilization and the charge neutralization. So what happens? The acid condition will cause the removal of water, the dehydration of these proteins will happen, as well as the charge neutralization. See, they would when they are being present already suspended in the milk because of the hydrophilic property of casein, what happens? The charge repulsion also will be happening. That would is a normal thing in which the milk will not agglomerate into lumps. But once this has been destabilized by the presence of alcohol during the alcohol test, or naturally due to the action of microbial activity, what happens? The proteins gets agglomerated and they form into lumps. Now next is the alcohol alizarin test. Here, along with the alcohol, you also had another dye called the alizarin is been added, so that this dye can change color depending upon the acidity level. So alcohol alizarin solution is normally bought, and you can add it into the alcohol. You can add some alizarin powder and make it into alcohol alizarin solution. So not only you know that the presence of alcohol is there or not, okay, you also know that what is the acidity of it. Okay, you know what, basically we are checking how much lactic acid has been formed here in the milk, and what happens, you mix it with some alcohol, it neutralizes, that's how it happens. And when the acid depending upon the amount of acid which has been present there, the alizarin will change the color. Here, this is what, if you have a normal milk, a pH of 6.6 to 6.7, you have a red brown color, and if slightly acidic milk, you have a yellowish brown color, and if it comes to acid milk, it becomes yellowish, and alkaline milk, it becomes lilac. So depending upon this, we can be able to interpret what is the acidity of the milk. Now in the case of alkaline milk, they appear lilac, and it's mainly due to the presence of like mastitis milk, and clots and flakes too indicate the mastitis milk. And the sour milks look like yellowish with small clumps and completely coagulated ones. I think we can stop with this topic right now, because the direct microbial count will take a little more. So thank you.